Welcome to Real World Learning Center. In our previous session, we started the discussion about the real world problems, the scenarios where you use the concepts what you have studied under numbers in real life scenario. Especially we saw about how to find the least possible number to multiply a given number to get the perfect square, and how to find the square root of that perfect square. We saw that, and now we would like to see much more interesting problems. Word problems, which actually discuss about the real world scenarios, and especially using the concepts of HCF, highest common factor, and LCM, least common multiple. So let's start the discussion. Okay, very interesting problem number 2. So we have got word problem here and a practical real life scenario. Now Deepthi, she used a piece of cloth to stitch a curtain, and after stitching the curtain, she was left with a piece of cloth which is 80 cm by 120 cm. She was left with the cloth 80 cm by 120 cm. Now, she didn't want to waste the piece of cloth. So she wanted to stitch handkerchiefs, cut it into handkerchiefs. So what she thought is, let me have handkerchiefs which are having largest possible size, avoiding any wastage. She didn't want to waste any piece of cloth. She wants to maximize the output, the usage of the cloth. So how many handkerchiefs could she make? And the condition is, handkerchief must be square. Okay. Now how to do it? So when you read the problem, it appears a bit complicated. But now start breaking down the problem. Try to understand the problem by going through it once again and try to locate some interesting keywords, what do we call as important words in the question. Now what are the important words? Again, I have highlighted the important words. Here you can see the word cut. Cut means you have to reduce it into smaller size. That is one important word. And again, equal sized handkerchiefs. Okay, that's size of all the handkerchiefs must have equal size. So if you remember our discussion on factors and multiples, we have dealt with given a certain number of say objects like apples or any other object, how do you split into equal sized groups? If you remember the discussion there, here it will be of some use to you, because I am telling equal sized. All of them must have equal size. And the third condition you can see is largest possible size. So these are the keywords. One is cut given cloth and reduce it in size, and then but have equal size, and then largest possible size. Okay, and of course avoiding any wastage. So now, having noted the keywords, let's start solving the problem. So solution steps. Now, since we need to divide the cloth into equal sized piece, we need to find common factor. Why common factor? Because equal sided. If you have a square here, okay, this particular length and this particular length must be same. Okay, going forward like this, suppose you have one more, now this side length is same size. Similarly, same length is here. Okay, since you have to divide the given cloth into equal sided, so we have to use common factors, because it has to be factor of both and it has to be the same number. That's why common factor. The length of this side must be same as this side, so it's a common factor. And now, since I need the maximum possible size, given two numbers you can have many factors, but since I want largest sized handkerchief, so I have to go for the highest common factor. So these are the important keywords. So go for highest common factor. Now the task reduces to finding the highest common factor of 80 and 120 of 80 and 120. Okay, once you obtain the HCF, you will get the side length, this particular side length, and having once got the side length, now I know how many sides are here and how many sides are here. So once you find the number of sides here and number of sides here, I can multiply those two to get the total number of handkerchiefs. How to do it, I will explain. Now let us find the common factors first of 80 and 120. The common factor of HCF, I am using a prime factorization method here. 2, again 2, again 2, again 2 5s are. Okay, so 80, okay, let it be here, then 120 I will do here, and I'll do 120 here, 260 and 230 and 215, 3 5s are. Okay, fine. So now I have to find the common factors. So 80 is equal to 2 4 times, 5 ones, and here 120 is equal to 2 3 times, 3 ones, 5 ones. And to find the highest common factor, if you remember, I have to take the least power here. Which is the least power here? Here, this. And 3 least power, this is 0, it's not here, so they take that. 5 least power is 1, take that. So now we get HCF of 80 and 120 is equal to 2 cube into 5. 2 cube is 8, 8 5s are 40. 40 is the highest common factor. So the side length of each is 40. So here, now since it is 40, it's about half, 80 here, 40. So it's somewhere comes here, and the 120 is split into 3 parts. Yeah, so it's something like this. Okay, 1, 2, like that. You consider here. So 1, 2, 3, 4, 5, 6. Total there are 6 handkerchiefs. But how did I get the number 6 here? What do I do? So here the total, side length is, total side length is 80. Now I have to divide it by 40 because individual side length here of each handkerchief is 40. How many handkerchiefs are possible vertically? So there are 2 handkerchiefs, you can keep it here. Okay, now how many are possible like this? Now 120 is side length, here by 40, 3. So I can place 3 handkerchiefs like this. Now what is the total number of handkerchiefs? 1, 2, 3, 4, 5, 6, nothing but 2 into 3. So total number of handkerchiefs is 6. How did I get the answer? Very simple. Give a number, find HCF. After finding HCF, it's 40. I divide each number by the HCF, and you get the quotients. Multiply the quotients, you will get the total number of handkerchiefs. I hope this problem interested you a lot. And similar problems I want you to try out to further strengthen your understanding of highest common factor. Remember, try to look at the problem carefully and pick those key words, important words, where one thing is you should know it should be a factor. Factor means you have to either divide it or cut it, and then you should have common, equal sized, or you should have both together. So here we have got square. Square means both are having equal side, so hence it has to be a common factor. And then why highest? Because you have a larger size or largest possible size you need to have. So it is highest common factor. So like this, look for the keywords, then you will be able to easily solve the problem by understanding that you have to use the concept of highest common factor to solve it. Now for you to get and strengthen the concept further, I have some practice problems. Try to do them. So we have got a couple of practice problems. First problem here. A carpenter got some free wood and wooden planks, and naturally will be very happy. He wants to make use of it. So, a given plank, one of them is 16 feet, other is 24 feet. So in order to use it to his benefit, he wants to cut those planks into equal sized planks. Now, how to cut it? Point is, while cutting, remember the word cut and remember the word equal size. Now what he has to do is, he wants to maximize. Okay, he wants to maximize the size of this plank, smaller plank, maximize the size of it. How to do it? And no wastage, by the keyword no wastage. So, perfectly divisible factor means no wastage. That's why we use it. We want to use the concept of common factors here. Maximize the size, highest common factor. I hope you can solve it. Now we'll take another practice problem. Mrs. Evans, she has 120 crayons and 30 pieces of paper. Now she wants to distribute it among her students. And what is the largest possible capacity of the classroom? Largest possible number of students she can have in her class, so that each student gets equal number of crayons, okay, and equal number of paper. I can see the keyword largest possible student size and equal number of crayons, equal pieces of paper. I hope you got the clue and solve this problem. Now, having studied a problem based on HCF, we would like to also see problem based on LCM, least count multiples. Let's go ahead. Problem number 3. Again, a real world problem, quite interesting problem. Now, Deepika exercises every 12 days, once in 12 days, and Ramu exercises every 8 days. Okay, Deepika exercises every 12 days, once in 12 days, and Ramu exercises once in 8 days. Both of them exercised today. The day when you read this problem, both of them exercised today. And now, how many days will it take for them until they exercise together again? For the second time. They have exercised today. Now, they have to, they will exercise regularly, period of 12 days for Deepika and 8 days for Ram. But again, they have to exercise together. Okay. So, how will they do, which day they will exercise together again? Now, again, as I told you, search for keywords in the problem. What are the keywords here? Okay, the keywords is, you can see, together. They exercise together on the same day. And what do we want? We also want to see the immediate next time when they exercise together. Now, they may exercise together many days, and for many days after today, but I want to know the immediate upcoming day. So here, these are the important keywords. Now, having seen these keywords, we can come to the understanding that we need to find certain common things, because together they have to come again. And we also have to, get that date with immediate effect, means immediate possible date, that is the least possible common day. Since we need to find the days where they would exercise together, we need to find common multiples of their days. Common multiples, why common multiples? Because now, take Deepika, I am just using the short form as D. She is exercised today, that is 0, consider, okay, and then she exercises together again after 12 days, and then she exercises again after 24 days, again after 36 days, goes on, okay, and now Ramu, he exercised today, and then after 8 days, and then after 16. So like this, he goes on exercising with the interval of 8 days, she will go on exercising with the interval of 12 days. Okay, that's why it's multiples. Why common multiples? Because they have to come together again. So here if you see, they have come together again after 24th day. Similarly, if it continues, then it's 32 and 40 and 48, and here it is 48. So like this, there are many days where they would come together again. Okay, so common multiples. But since I have to find the immediate possible next day, okay, so I have to find the least common multiple. So here I have used the technique of multiplying, adding 12 consecutively, 0, 12, 24, 12 ones are 12, 12 twos are 24, 12 threes are 36, 12 fours are 48. Here I have used 8, 8 ones are 8, 8 twos are 16, 8 threes are 24, 8 fours are 32, 8 fives are 40. It goes on like that. So I have multiplied the given number starting from 0, 1, 2, and then I found out the least common multiple, that is 24. The least common multiple. Okay, so finding the least common multiple, we get the upcoming day where they would do it together again. Now, instead of finding all the possible multiples, I can use prime factorization technique. What will I do? I will find the prime factors of 12. And I will find the prime factors of 8. Sorry, I have to find the highest possible power. Okay, LCM of 8 and 12, highest power here 2 cube 2 square 2 cube, and here 3 is another, but 3 highest power is here, see, equal to 8 into 3, 4. So after 24 days they would exist again together for the second day. Now, having understood this particular problem, how to solve it, now I would want you to practice more problems. So I have got a couple of more very interesting problems. So one of the problems is listed here. You can see the problem here. A telecom company, the company wants to target more customers, in the sense it wants to increase the number of customers, so it is giving certain offers. So what is the offer? It wants to give away a rupee 500 gift coupon. We have termed it as bill. It is nothing but a gift coupon. So for every 100th caller, the 100th caller would get rupee 500 gift coupon. And every 30th caller will receive a free movie ticket. So every 100th caller will get gift coupon of 500 rupees, and every 30th caller will get a movie ticket. Okay, how many callers must get through? People start calling, first caller, second caller, then 30th caller, I will get a movie ticket, then again 31st, then 50, and 60th caller, he will get a movie ticket again, 61st, and 70, 80, 90th caller, again he will get a movie ticket, and then 99th, 100th caller will get a gift coupon of 500 rupees, and then 101th caller, then 120th caller will again get a movie ticket. So like this it goes on. How many callers must get through before one of them receives both a coupon and a concert ticket? Again the common multiple here. Okay, so multiples of 30 will get a movie ticket, multiples of 100 will get gift coupon. Find that particular caller, number of the caller, who will get both a movie ticket and a gift coupon. So the task is left to you to solve. Now we will see another interesting problem. Problem is as below here. There is a particular bus stop, and bus with number 90A and bus with number 95B, both of them stopped at this particular bus stop at 12 noon. And buses with bus number 98, they stop here every 20 minutes. And with number 95B, stop every 8 minutes. Okay, frequency. Every 20 minutes you get a 98 bus at this stop, and every 8 minutes you get a 95B bus at this stop. Now at 12 noon, both of them stopped together. And now, when will both the buses, buses with number 98 and 95B, stop there again at the same immediate next time? So again, why it is common? Because they would come together, and why it is multiple? Because they would repeat. They would repeat after, say 98 would repeat after every 20 minutes, and 95B will repeat after every 8 minutes. So multiple. And why least? Because the immediate next time where they would stop together. And I hope you got the idea of how to solve this problem. So like this, whatever concepts you have studied in this particular unit on numbers, you can actually apply in various real world scenarios. Only thing is, you need to have that presence of mind whenever you come across such problems, which particular concept will be of use to you. Especially we have seen the concept of HCF and LCM of being of so direct immediate use in our real world scenario. Hope this interests you further to dig into these concepts and get a grasp of these concepts, so that you would be able to apply these concepts in real world scenarios. That's it for today. Thank you.